Have you heard about the latest gadgets making waves in solar cell research? They're called perovskite solar cells. They're generating quite a buzz because they're quickly getting better and better at converting sunlight to electricity, and because they can be made simply and inexpensively by using common wet chemistry lab methods and ordinary low-cost equipment, instead of the expensive deposition equipment common in the semiconductor industry. Step inside labs at Notre Dame and Northwestern universities to see some of the methods that make this process cheap and accessible. Every lab tweaks the procedure to suit its research focus, but many of the steps are common to all researchers studying perovskite cells. These solar cells, or photovoltaic cells, are typically made in a layer-by-layer fashion on a specially coated glass support. This particular lab first treats the coated glass with a dense layer of titanium dioxide to prevent electrical charge generated by sunlight from leaking out of the cell. This robotic arm forms that layer by spraying a titanium dioxide solution onto the glass. Next, a less dense porous oxide layer covers the dense oxide layer. Generally, it's titanium dioxide, but other oxides have been used as well. A simple high-speed spin coater deposits this layer from solution and spreads it evenly across the device. Heating in an oven conditions it for solar cell use. Next up is the perovskite material, which absorbs an especially broad range of the solar spectrum. To prepare the perovskite used in this lab, these researchers combine two precursor materials, lead iodide and methyl ammonium iodide. They drip the liquid phase mixture onto the oxide-coated device and give it a spin to spread the film uniformly. Now comes the color-coordinated fun part, and all it takes is an ordinary lab hot plate. Gently heating the device after applying the halide solution spontaneously crystallizes the precursors in the freshly deposited liquid. In this example, they're forming methyl ammonium lead iodide, which adopts the well-known perovskite crystal structure after which these solar cells are named. It's easy to know when the precursors undergo crystallization. The color change is pretty obvious. After completing a few more steps, the device is ready for testing. Hook it up, turn on a solar simulator, such as a laboratory xenon lamp, and voila! This little device transforms light energy to electricity. You probably won't find perovskite solar cells on rooftops, at least not in large numbers, anytime soon. But judging from the recent explosion in research popularity, these low-cost photovoltaic cells are likely to show up soon in a lab near you. For Chemical and Engineering News, I'm Mitch Jacoby.